Hi there. I've gotten several questions about interval notation. So we're going to do a real quick little video reminder of what interval notation is. If you're not quite sure what I'm talking about, when we talk about frequency tables and classes, sometimes you see an interval written like this. And then the next one says 25 to 30, and then 30 to 35. And then confusion happens because you say, well, there's a 25 right here and a 25 right here. Where do I put the 25? And then once you figure that, you think, okay, well, there's a 30 here and a 30 here. Where the heck do I put the 30? So let's see if we can clear that up. When you have square brackets, it means include that number. It comes from using the less than and greater than or equal to symbols. Remember that the two little lines underneath stand for equal to. So we could use any number greater than or equal to that number or less than or equal to that number. When you have the normal parentheses, we don't include that number. This comes from the strictly less than and strictly greater than symbols. Those are not necessarily in the right order. I'm going to flip them around because somebody's going to email me and say, Ms. Graham, you did that wrong. This would be greater than or equal to, less than or equal to. And this would be greater than and less than, to put them in the same order as the brackets or the parentheses. Well, then the question becomes, what do you mean don't include that number? Why don't you just change the interval? So, for example, maybe your interval went from 3, to 7, but we don't want to include 3 or 7. This is where we have to think beyond the realm of whole numbers. Maybe you have numbers like 2.9, 3.001, 4, 6.7, 5.2, 7, and 7.00001, and let's, just for grins, we'll throw in that guy. If we just change the interval, maybe we change it to 4 to 6. If we don't want to include 3 or 7, maybe four to 6. Well, that would leave out some of our data. That would leave out this guy. That would leave out this guy. And so we can't just change the interval. Once we bring in the decimals and the fractions and all those super fun things, we have to come up with symbols that make our stuff work. So if I want the interval, the open interval, that's what we call it. This is an open interval. This is a closed interval. Right now, we're just going to look at the open interval. That means we want to be greater than 3. Well, that means 2.9 is out. 3.001 is greater than 3. 4 is greater than 3. It looks like all of these are bigger than 3. But we want to be less than 7. So that means 7 is out. 7.00001 is out. But the 6.99991 gets to stay. So we include these guys in our interval. Now, as soon as I change that, but not like that. Don't do it that way. If I do 3 to 7 and I close the bracket, we call this a half open interval. Which is really more than you need to know for this. We still want to be greater than 3, so the 2.9 is still out. The 3001 would work. 4 would work. 6.7 is still in there. 5.2 is still in there. But now we include 7. So 7 gets added. 7.00001 is still out. The 6.9999, I don't know, 1, however many 9s are in there, is still in there. If you need a visual, because I know math can make more sense in pictures. If you go back to your good old-fashioned number line, we'll stick a 0. I'm going to move my 0. We'll put 8 back here. This is a good spot for the 3. That's a good spot for the 7. The open interval means we would have a circle at 3, because we can't touch the 3, and a closed dot at the 7, meaning we can touch the 7. And everything in the middle counts. So, in our intervals, it means we put 20 here. We keep the 20, and we lose the 25. The 25 gets bumped to the next one. But we kick the 30 out. 30 gets bumped. That does not say keep. We lose the 35. So that is a brief review of intervals.